The LEAP-1B engine. So this LEAP CFM manufacture this engine in three different classifications. They have the LEAP-1A, which is installed on the Airbus 320 series aircraft. They have the LEAP-1B, which is installed on the Boeing Max 737 Max. And they have the LEAP-1C, which is installed on the Chinese manufactured, I think it's called Comac aircraft, which resembles very much a 320 737 series aircraft. So we mentioned before that the strut or pylon allows for attachment of the forward and aft engine mounts. The cowlings provide a smooth surface around the engine. Once they're closed, then they provide a nice smooth surface. The inlet cowl attaches to the front of the engine fan case, this one here. The fan cowl is attached to a support beam that is on the top of the fan case. And the thrust reverser cowls attached to the strut and also transmit reverse thrust to the aeroplane after landing. These are the thrust reverser cowlings, 1, 2. The fan cowls have access panels for engine servicing. So these are ones at the front, and you have access to the IDG and all the more frequently accessible items that you need. The oil servicing panel, for example, a thing called ODMS, which we'll see in a minute. There's also on the inboard cowling a vortex control device. You might have heard it as a strake or a control device, whatever. It's just used to improve the airflow on that side of the engine, because you have to imagine here, exactly where I'm pointing, sits a wing where air gushes over at extremely high speeds sometimes. So that vortex control device sort of lines the air up for a smooth transition onto the wing, big fat leading edge of the wing that reduces a lot of lift, a lot of airflow there. The engine core is a new tech design with improvements. We said that GE went out of their way to make a lot of improvement. There's a lot of ceramics used in this engine, which they've improved the temperature resilience of this engine. There's a lot of carbon fiber. All the fan blades are carbon fiber. The barrel that is all this here, the LP barrel, the LP case is all sheets of carbon fiber. So they've reduced it by a third of its weight. So there's a significant weight improvement, and there's a significant performance improvement in terms of the materials that GE have set out to use on this engine. And the usual construction of a CFM or any engine, the main gearbox supplies power for the aircraft and engine accessories. Here is what it looks like on the left-hand side with all the components. You got the the main fuel oil heat exchanger. You've got the fuel metering unit, the fuel flow meter. As you can see, all the fuel sides are predominantly on the left-hand side of the engine. You got the pre-cooler. Now the pre-cooler, usually this one here, is not a part of the engine. Okay, this is part of the aircraft. So this is where the strut would come, and right underneath the strut sits the pre-cooler. So when you change the engine, you fit the pre-cooler, or you fit the engine into the pre-cooler. All right, just so we get that clear. We got the low pressure and the high pressure active clearance control valves. We got the split control unit servo valve assembly. We got the ignition exciters. You can't really see them here, but they're fitted around 4 o'clock and 7 o'clock on the underside of the engine. The fuel differential pressure switch, the fuel filter, the lubrication pump, the starter, the IDG, the permanent magnet alternator, the PMA, the fuel pump, the fuel strainer, differential pressure sensor, the hydraulic pump, and the fuel oil cooler. As we said, predominantly fuel on this side, and therefore more engine control, air, and oil on the other side. So we have, on this side, we have the EEC channel A, EEC channel B, the pressure subsystem box. Okay, so the pressure subsystem box is a box that combines these two, the crosstalks with these two, and provides alternate data if one of these EECs goes US. It also has all the information of the engine thrust settings, and also all the bleed, all the air settings, all the bleed PS3, all the bleed data go to this pressure subsystem box that then will talk to the FADEC, to the EEC, to make this engine as efficient as possible, or let the AEC do its job. We've got EEC blowing, cooling blowers. So down here, which have subsequently, they were installed on the first, I'd say 100 aircraft, and they were subsequently removed through a service bulletin. They no longer exist. So the chances of you seeing a MAX with these is very, very, very remote. Okay. We have a lubriclone debris monitoring system. Okay, so it's a bit of a chip detector that can be, it's monitored. In other words, there's a cockpit indication for it if the debris becomes too much for the liking of the engine's operation. We have the oil tank there. We have a drain mast here. And we have the start bleed boost anti-ice valve. And the transient bleed valve. Okay, all down in the hot section of the engine. In terms of engine indications, we already have the EI page displayed, and we saw that the max display system, the MDS, shows the N1, so it's a percentage RPM with exceedance indications. N2, which is in percentage RPM with exceedance indications, EGT in degrees Celsius or Fahrenheit, depends how your aircraft is configured, which part of the world you live in, with exceedance indications. If any exceedance occurs, we get a red box around each digital indication, and it will stay on after shutdown. What else will come on? Maintenance light. And until that light is extinguished, the aircraft will not be able to fly again. Other indications, we said we have fuel flow, also total fuel used per engine, the engine oil pressure, the engine oil temperature. Again, it can be degrees or Celsius or Fahrenheit, depending which part of the world you live in. The oil pressure and temp become amber or red when there's an exceedance. Really important, guys. The oil pressure. The oil pressure is the most important thing if you're doing maintenance runs. And if you have a red indication, you have to follow the instructions and immediately shut the engine down. Otherwise, it might blow up. Okay, the engine quantity is indicated in watts with a thing called reverse video. So if you go below a certain amount, the video becomes, the normal indication is usually white on a black screen background. Reverse video means the background goes white and the indication goes black, just so that it gets your attention to it. Okay. We have the same principle for engine vibration, which engine vibration is in scalar units, and above a certain threshold, it will go into reverse video and indicate black on a white background rather than white on a black background like the left one is. The FADEC control functions. So it controls the fuel flow to meet the thrust lever angle demand. It controls the servo control systems. It has an input over the engine fault detection and fault storage. It enables communication with other aircraft systems between the engine, and other aircraft systems. There is a PMA, an engine-driven PMA, so it's on the gearbox, accessory gearbox, where it will supply the power to the EC as long as the engine is running. Therefore, the gearbox is running. Therefore, the PMA is turning. Therefore, enough electricity is being produced to provide power to the EEC. Which, by the way, has a normal and an alternate mode of operation, just like the NG. The ECs control and monitor the split control unit. Okay, the split control unit is a unit where we'll see in a minute, it takes the fuel goes into the split control unit, and the split control unit then, upon indications and commands from the EEC, will distribute the fuel. One way to burn it, and another way to use as muscle pressure for all the active clearance control valves and the MTC and the VSVs and the VBVs, etc. Okay, in terms of fuel system, the functions. So here's a circuit diagram of the fuel, which basically is used to supply pressurized, heated, and filtered fuel to the engine, the fuel metering unit for combustion, and to the SCU, which will then distribute it, as we said just before, to the different users up here, which are the high pressure turbine active clearance control, low pressure turbine active clearance control, the MTC, the transient bleed valve, the ASBV boost anti-ice valve, the VSVs and the VBVs. Okay, so these are opened or commanded or commanded to open or close. They're bleed valves. They open and close. It's air that goes through these valves, but the medium to open and close these valves is muscle pressure fuel, okay, from the split control unit. No different to other engines that we know. The oil diagram here, it lubricates, cleans, removes heat from the engine. Okay, so we talked about it's the usual function, guys. It goes from the tank, okay, through the oil supply pump. It gets strained through the filter. They try to use hot oil to cool fuel down, and this thing here, and also heat the fuel up a bit. So it's a two-way heat exchanger, fuel oil cooler, and heater, and it eventually goes to all the bearings here in the engine and comes out from the bearings into the sumps and through all these scavenge pumps here. They will return it back to the tank. Before they return it to the tank, we have this new function here, this oil debris monitor sensor, the ODMS, which is basically a chip detector that is monitored. So before the hot oil goes back into the tank and it's going to be reused again, we collect any material from it through this chip detector. And this has a little bit of circuitry here that will give an indication, an electrical signal to the DPC. And the DPC will then put it on the display unit if it exceeds a certain amount. A picture of the air. So bleed air comes from the high pressure compressor. So that's the N2 part for air conditioning, cabin pressurization, wing and engine, inlet cowl anti-ice. No different to any other engine. In fact, in the respect that this works, it's more or less the same as the CFM series of engines. It's how it does it that differs, that GE pulled out all the stops, but the principle of it is still the same. So for the engines, we now have system faults and byte engine faults. If you can recall from the NG, we had a little on the MCDU, a little troubleshooting where we could do some minimalistic troubleshooting, check some VBV, VSV valves, some actuator tests, an EEC test, very limited operations for troubleshooting. Here we have not only can we see the faults, we can see the different levels of faults that can impact the operation of the engine. So some faults, for example, will affect the economic operation of the engine, higher fuel consumption or whatever, and other faults will affect the airworthiness. So if they affect the airworthiness, what will happen? The maintenance light will come on. Okay, so, and then it's the job of the engineer to perform the necessary action required to extinguish that light. And only when that light is extinguished can the aircraft be recertified as serviceable again. The MAX display system has 4 maintenance data pages that show engine sensor and component information, similar to the wide bodies, if you can recall. And these are all different parameters of the engine, including also exceedances. So you can see, for example, if you had an overheat or an AGT exceedance, you could see the maximum, the peak temperature, and for how long, how many seconds, etc. Which those figures would give you a specific FIM code to follow for that amount of exceedance. Okay. All right. Now, our membership is made up of 2 parts. There's a library resources, and there's a community to connect with myself and others. It's different from any other online training platform you might have been part of, as it has the human element with it. We don't just sell you a course and then send you on your way. We're there to support you and motivate you. So if you're stuck, there's real people there to reach out to. So here you'll find many resources organized in a way to save you time. Everything's mapped out from starting your career to getting your license to your first type rating to upskilling your qualifications. There's many non-mandatory courses, just like this one, that you can take that come with certificates so that you can be building your skill set ready to impress your next employer. The AME community, this is the other part of the membership, and this is where the magic happens. So inside the community, which you can see here, can be on your phone, you'll find forums where you can get help every single day. You don't have to go to Facebook anymore to look for support and spend hours scrolling and hoping to find the answers to your questions. You can now ask in a place where you can be sure to get the right information. If we don't know the answer to your question, somebody in the membership, or we will find somebody that does know the answer to the question. Everything you need is at your fingertips and easy to find in a user-friendly app that you can download. The community is a great place to make connections that are lasting and that will help you as you move along your journey. You can take part in as many or as little as you like. You decide. We do charge a fee for this, and you might be asking yourself why. Well, research shows that if something is free, you're less likely to use it. If you pay for something, it automatically creates accountability, makes you want to get your money's worth. Sorry, makes you want to get your money's worth and do the trainings and be active in the community. You may feel that $200 is a lot of money to pay in one chunk, but think of it not as a cost, but as an investment. Why not give yourself 12 months of support, resources, connections, trainings, and be part of a professional community, not just another Facebook group? We will be raising our prices next year as the amount of resources in the library grows. But if you join now, you will stay at the low rate for the whole time you're a member. And there's more, the annual fee will keep going up. So it pays to do it sooner rather than later, because you will be on the starting rate, which is the one on the top left of this picture here. Okay, so we will be raising the prices. There's trainings being added all the time. We've got some exciting courses coming in 2025. Just as a small tip, we've got an EASA 145, FAA 135 compliant ATR Gen FAM course, which is coming up, which will be available in the library with certificate next year, which, if you remember, will be absolutely free. Okay, so and as time goes by, we intend to put more and more courses in all the time.